We're going to talk today about the piecewise function. So we're going to go through a couple of different examples. You can take a few notes, and then I'm going to have some for you to do tomorrow in class. So first, let's start off with what is a piecewise function. So a function is something that is a function that has been defined in pieces. What I mean by that is here's a function that's got two parts. It's got the top part, 2x plus 3. That part's only defined when x is less than or equal to 0. And it's got the bottom part, the 3x minus 4. That's only defined when x is greater than 0. So your first step is to understand how to go about evaluating the function when you plug in numbers. So for example, f of negative 3. That would mean you would need to plug negative 3 into the function, but you have two pieces. So which piece do you plug it into? Well, you plug it into the top one because negative 3 is less than 0. So it's got to go into the top function. And if you do that, you get 2 times negative 3 plus 3, and you get negative 3 as your answer. Well, what about f of 6? Well, 6 is greater than 0, so it's got to be plugged into the bottom function, bottom part of the function. So if you do that, you get 3x minus 4, or 3 times 6 minus 4, and that winds up being 14. What about f of 5? Well, where do you plug it in? Well, 5 is greater than 0, so you got to plug that into the bottom one. You plug that into the bottom one, that gives you a value of 11. What about negative 2? Well, negative 2 is less than 0, so it's got to go into the top one, and that gives you a value of negative 1. What about 0? Where does that go? Well, 0 would go into the top one because the top one says less than or equal to 0. So therefore, it's got to go into that top function, and that gives you a value of 3. Now, piecewise functions don't have to be just two parts. They can be multiple parts. So in this case, we have a piecewise function that has three pieces. So when you're evaluating it, f of 0, where's that going to go? Well, that would go into the middle one because 0 is between negative 3 and 2. So plug it into the middle one and you get 4 as your answer. What about negative 5? Well, negative 5 is less than negative 3, so it's going to go into the top one and you're going to square it and you're going to get 25. What about 4? Well, 4 is greater than 2, so 4 goes into the bottom one. Plug that in, you get 3. What about these guys? Well, 3 is greater than 2, so it's going to go into the bottom one. Negative 3 is going to go into the second one, the red one, because it's negative 3 is less than or equal to. And then negative 4, well, it's less than negative 3, so it's going to go into the top one. So there you plug them in and you can see your answers. Now, in piecewise functions, plugging them in is not the problem. The problem usually comes when graphing them. But before we start graphing them, let's talk about domains and ranges of these functions. So this is what the graph of a piecewise function might look like. And you can kind of see why it's called a piecewise function. It's got different pieces. The domain is are the x values. What x values does this function exist for? Well, if we take a look at it, it starts way on the left at negative 7. But it doesn't quite include negative 7. It's got an open circle there. And then as we trace it across, it goes all the way across from negative 7, which is way over here, all the way over. What happened there? It goes from negative 7 all the way over until it gets to positive 7. However, if you'll notice, right here in the middle, it doesn't actually include negative 1. So when we write our domain is from negative 7 to negative 1, not including negative 7. That's why it's got the parentheses. It skips over, that's what this part means, it skips over right there. And then it goes up to 7, but it includes 7 because it actually has a dot. These are your x values. The range, that's your y values. So for your range, it's going to start at negative 1, which is right down here at negative 1. And then it's going to go all the way up until it gets to 5, which is right there. But then it skips right there and goes to 6. All right, let's do another one. So here's another set of piecewise functions. So from domain, where's the domain? The domain starts right there. It goes all the way over, but it looks like it skips right in here, skips right in there, and then it stops right there. So your domain then starts at negative 7, goes all the way over, skips over from 4 to 5. Notice how it skips from 4 to 5, and then it continues on its way till 7. The range starts down here, goes up to -5, but then it's got a big jump right there. There's the big jump. And then it goes from 2 all the way up to 7. All right, so that's the way we handle domain and ranges of these things. Now, what about if we're actually being asked to graph them? So here's the way we're going to graph them. We have 3 pieces, so we're going to graph the 3 parts. We're going to start with x is less than -4, which is the blue one. So what I'm going to do is I'm going to plug -4 into the function. So if I plug -4 into the blue function, that's going to give me 0. I'm going to use an open circle because it doesn't actually equal -4, right? It just has a less than. So anytime it has a less than or a greater than, we use an open circle. But if it has a less than or equal to, then we use a closed dot. So there, if I plug -4 into the red function, the red part of the function, 2 times -4 is -8, plus 5 is -3. That one gets a solid dot because it has an equal. Then I'm going to plug in 1. That's the next waypoint that you can call it. If I plug in 1, 2 times 1 is 2, plus 5 is 7, so it's going to go all the way up there at 7. And then lastly, I'm going to plug in 1 again, this time into the green one. If I plug 1 into the green one, I get -1 plus 3, which is 2, but that's an open circle because it doesn't have an equal sign. And then I need to draw my lines. Now the slope, x plus 4, the blue part of the function, it has a slope of 1, so it's going to look like that, right? That's what has a slope of 1, and it keeps going forever. The red dots, just connect them. It's a line. It just makes a straight line. And then the green one, it has a slope of -1, so I go down 1 and over 1 and down 1 and over 1, and that gives me a line that looks like that, and there's my 3 pieces. And then we can do the domain and the range the way we did the previous page. The domain, because it has arrows, it keeps going from the left and the right forever, so -infinity to +infinity. And the range, well, the range, it starts way up at 7 and goes down to -4, to -infinity, keeps going down forever, those arrows. This error there, that's a typo. That should be a bracket because this is a solid dot up here, right? So if you notice that solid dot. All right, let's do one more. -1/3 x. So this is a 4-parter. So I'm going to plug -6 into the -1/3 x part. Plug that in first. So -1/3 times -6 is +2. It gets a solid dot because of the equal sign. Then I'm going to plug -3 in. If I plug -1/3 times -3, that's a +1. Again, a solid dot because of the equal sign. And then I can connect those 2 dots. Right? It's just a straight line. Then I'm going to plug -3, this -3 right there. I'm going to plug that in again to -3 plus 1. That's going to give me -2, but it's an open circle because there's no equal sign. Then I'm going to plug in 0. 0 plus 1 is 1, and it's going to be a solid dot because it has an equal sign. And then again, x plus 1 is just a straight line, so straight line. Then I'm going to plug in 0 one more time. I'm going to plug 0 in here. 0 plus 4 is 4, open circle because there's no equal sign. Then I'm going to plug in 3. 3 plus 4 is 7, open circle, again, no equal sign. Connect the dots. And then do the last piece. Plug in 3, -3 plus 3 is 0, open circle because of the equal sign. Plug in 7, and I get -4, closed dot because of the equal sign. Sorry, I said, yeah, the 3, that's why they were both closed dots. And then you connect the dots. As far as the domain is concerned, it starts at -6, which is way out here, and it goes all the way to 7, which is way out there, and it doesn't jump or anything like that. The range starts down here, and it goes all the way up to here. However, it does skip over that part right there. So it goes up to 2, and then it skips over 2, and it keeps going on to 4. So that's how you graph piecewise functions. So what I'd like for you to do next, in OneNote, there is a worksheet titled Intro to Piecewise Functions, and it has 2 piecewise functions on it. I want you to try to do those on your own And then when you come in tomorrow, we're going to talk about them. Good luck.